Hello, so in this video I'm going to talk a little bit about limits at infinity. Now, limits at infinity deals with looking at a function and seeing like what happens if x becomes arbitrarily big. So like, for example, if I look at the limit as x approaches infinity for 1 over x squared, I can see that the values are getting smaller and smaller, which means that they tend to 0. Okay, well, if that's the case, then we also have that if we look at negative infinity for 1 over x squared, that also goes to 0. Now, let's say that we're looking at a different function of which that we have that we want to see what happens similarly if you have, let's say, okay, let's say that we have this equation right here. Didn't mean to do that. Okay, so let's just draw it again. Okay, so let's say that this is our equation, and suppose that we have a horizontal line right here. And then maybe like down here as well. Okay, so we'll call this negative L. I'm sorry, negative L. And then we have that this will be L. Now, if we take the limit as x approaches infinity, and we'll say that this, for example, is y equals f of x. So if we take the limit of f of x, we have that it approaches the value L. Now, L is said to be a horizontal asymptote, which similarly, if we were to take the limit as x tends to negative infinity, so x tends to negative infinity for f of x, then that would be the same thing. It would be L. Now, what we can do is just look at a couple of examples on how do we find certain limits. So let's say that we want to find the limit as x approaches infinity for x plus 1 divided by x minus 1. Now, what I'm going to do with this one is I'm actually going to use the graph. So let's say that we go ahead and we just draw the graph of this one. So we have that there's a vertical asymptote at at 1 actually. So we have that there's an asymptote at 1, and then we have another one at 1 as well. So that'll be something like this. Okay, now obviously this is just a sketch. So we have that -1, -1. Okay, so that means that the graph will look something like this. Okay, so in that case we have that the graph goes like that. Okay, so looking at this graph, we can see that if we have that x tends to infinity, that this graph is just going to go closer and closer to the horizontal asymptote that we called 1, y equals to 1. So what this tells me is that I have that the limit as x approaches negative infinity, or infinity, that this is going to be x plus 1 divided by x minus 1, x minus 1, that equals to just 1. Okay, so that's one way that we can actually figure out, how do we determine the limit is by using the graph. Um, Now, what we can do furthermore is look at another example where maybe we won't use, say for example, the graph. So like if we have find the limit as x approaches infinity for 4 plus 2 divided by x squared. Now, this is actually pretty easy because we know that basically if you take the limit as x approaches infinity, well, the limit laws still basically apply for these type of limits. So we have that this is just going to be 4 plus 2 times the limit as x approaches infinity of 1 over x squared. But we just established that 1 over x squared is 0. So that's going to be 4 plus 2 times 0, which is actually just equal to 4. So that tells me that the limit is going to be 4. Now, if we go ahead and we try to look at some more limits at infinity, one thing though that we're going to have to consider is what happens with polynomials. So with polynomials, there is an easy way to do this. For example, if I consider a polynomial like x cubed, so like if I have x cubed, I have that x cubed looks something like this. Okay, so this is x cubed, but if you look at the behavior of the function, I have that basically that it's rising. Okay, so I have that it rises to the right. But that's another way of saying that it goes to infinity. But then similarly, I have that based on this, that this is falling to the left. So in turn, that's telling me that, yeah, the limit as x approaches infinity for x cubed, that's just positive infinity. And then similarly, I have that the limit as x approaches negative infinity for x cubed is negative infinity. Now, I can do the same thing for, say, for example, x squared. So for x squared, oh, sorry. Okay, so for x squared, we have that it's a parabola that looks something like this. But essentially, I have that for y equals to x squared, that if I look at the limit as x approaches infinity for x squared, I have that it's rising to the left and the right, which basically means that it goes to infinity, and that the limit as x approaches infinity, negative infinity, for x squared is equal to positive infinity. Okay, so in this case, this tells me several things. Okay, so I'm going to have to basically define a polynomial that we call p of x. P of x is a polynomial. Yeah, so p of x is a polynomial that says a sub n x to the n plus a n minus 1. And then we have x to the n minus 1 plus all the way down to a1x plus a0. Now, the easiest way to look at this is when you look at the degree in terms of like if it's even. So if n is even, then basically you have two cases. you have that an is positive, which if an is positive, well, that's just like the parabola where it's pointed upward. So that's another way of saying infinity. But if an is negative, well, that means that you have that the polynomial is tending towards minus infinity. Okay, so now we have that we can look at, for example, what if our degree of our polynomial n is odd? Well, if an is odd, or fn is odd, then basically you have two cases. You have that an is still positive, or you have that an is negative. Well, in both cases, you have that for the positive, it looks like this. But for the negative, you have that it's the opposite. You have that it rises to the left and that it falls to the right. Okay, so this actually tells us what the behavior of the polynomial would be. So, for example, if I write down that I want to find the limit as x approaches infinity of, okay, so in this case I have that this could be like -2, -2x cubed minus or plus 3x plus 1. Well, in this case, you would have to look at basically like what the polynomial degree is and what the coefficient is also. So we know that the leading term is -2x cubed. Okay, so I have that the n is odd, but I also have that an is negative. So in this case, we have that basically the end behavior of the polynomial, that is, that it looks something like this. So if that's the case, then that means that essentially that we have our limit. So our limit is going to go to minus infinity. So that means that, yeah, we have that the limit as x approaches infinity for -2x cubed plus 3x plus 1, that this is going to, we said, negative infinity. Why? Because it's falling to the right, which means that it's going to negative infinity. Now, we can apply this to also polynomials, not polynomials, but rational functions. So when we look at a rational function, basically we have sort of the same thing. We have that f of x is equal to p of x divided by q of x. Now, whenever we look at the limit as it goes to infinity, basically there is a rule of thumb for this. So let's say that basically that you have that this is going to be an to the xn for the leading term, and this is going to be bm, and that's going to be x to the m for the leading term of q. Now, the main thing that you would do to find, for example, like whenever you're looking at the limit as x approaches plus or minus infinity for f of x, is that you look at the different possibilities. So you have that you would look at the degrees. So if n and m are both equal, that means that the limit, so that means that the limit of f of x is equal to an over bn, b sub n, sorry. B sub, it actually doesn't matter because they're both equal, but it's going to be the ratio of the two. But you also have that if the degree is smaller, that means that basically that the rational expression is bottom heavy, so that's going to go to 0. But then you also have opposite wise that if it's greater on top, that the limit as x goes to plus or minus infinity for f of x, well, in this case, it's going to go to negative infinity or to positive infinity depending on the sign of the coefficients. So that's where it gets a little strange. So I can do an example where basically I just say that, consider f of x is equal to x divided by x squared plus 1. So if I take the limit, as x approaches infinity for x over x squared plus 1, well, I know that the limit, because of the fact that it's bottom heavy, you have the degree is 2 and the degree is 1, that it's going to be 0. However, the way that normally that we find the limit is by dividing by the highest degree, or the highest term, the leading term in the denominator, which means that you would technically have the limit as x approaches infinity of x divided by x squared divided by x squared over x squared plus 1 over x squared. But this is kind of interesting because basically it gives you the limit as x approaches infinity of 1 over x divided by 1 plus 1 over x squared. But essentially this gives you that the limit is going to be 0 divided by 1 plus 0, but that's still just 0. So the limit is 0, just as we stated back over here. Now, in this sense, this means that we can actually apply finding more limits of anything, for instance. So polynomials, basically, or rational functions. So let's say that we want to find the limit as x approaches infinity for 4x divided by 20 x plus 5. Now, basically, the way that I'm going to do this is I'm going to look at it like that, where I have that it goes to infinity. I have 4x divided by 20x plus 5. Now, what I'll do next is I'm going to basically just divide by x on top and bottom. So I have the limit as x approaches infinity of 4x divided by x divided by 20x over x plus 5 over x. Now, interestingly enough, this simplifies really nicely. It simplifies to the limit as x approaches infinity for 4 divided by 20 plus 5 over x. What this does is it gives me 4 divided by 20 plus 0, which is really just 1/5. So we figured out that the limit of this is actually just 1/5. Okay, and that's because actually they have the same degree. So whenever they have the same degree, technically you could have just said 4 over 5, or no, 4 over 20, and then that would have gave you the exact same thing where you would have just said, oh, okay, Well, that's just 1/5. Okay, so let's go ahead and look at another example where we try to figure out, what the end behavior is in this example. So suppose that you're trying to find the limit as x approaches negative infinity of, let's say that you have x cubed plus, okay, so plus 1 divided by x. Well, in this case, we have that it's top heavy, so we know that it's going to minus infinity over infinity. Okay, so what we will have to do for this one is we'll probably need to go ahead and say that, well, if we divide by, okay, so if we divide by the highest degree in the bottom, that's going to give us the limit as x approaches negative infinity. So that's going to be x cubed over x plus 1 over x divided by x over x. But this gives me the limit as x approaches negative infinity of x squared plus 1 over x divided by 1. Now, this is where you got to be careful. So if you take the limit as x approaches negative infinity, that will go to 0. So I know that this goes to 0. And I know that this is going to, I know that this is going to stay as 1. But notice that this right here, this is going to go to positive infinity because basically you have that for x squared, it rises to the left when it goes to negative infinity. So essentially we have that this equation or this expression is going to go to positive infinity. Now, that's not the only way that you could probably do this problem. I mean, you could have probably stated that, for example, that if you would have divided it into like x squared plus 1 over x, you would know that this is going to go to 0, but then you left over with this, and then the rest is just deciding, okay, well, that goes to positive infinity no matter what. But remember that technically that does not exist. It's just telling you like what it tends towards. Now, I'll kind of leave you with one last example. So for instance, like let's say that you want to find the limit as x approaches infinity for, okay, so let's say that you have x divided by the square root of x squared plus 1. Now, this one's a little tough because not many people realize that you can actually just rewrite the expression. You can rewrite the expression by saying that you have x and then you have the square root of, well, this is going to be a trick where we factor x squared out and we have that this is going to be 1 plus 1 over the square root of, 1 plus 1 over x squared. Now, okay, this is where it gets a little complicated because if we take the square root of x squared, that's actually the absolute value of x squared. So we have that that's going to go to infinity. This is going to be x, and this is divided by, this is divided by the absolute value of x, and then we have the square root of 1 plus 1 over x squared. Now, when we take the limit, okay, so notice that x is going to infinity. So what that means is that it's going to where x is positive. So in that case, this is going to reduce to the limit as x approaches infinity of 1 divided by the square root of 1 plus 1 over x squared. But if we take the limit of this, basically you're going to find that you're going to end up with 1 divided by 1 plus 0, but that's still just equal to 1. Now, I know that you could have probably did that way easier, like such as like if you just plugged it into the calculator, or if you just said, well, isn't that just x? But note that if you would have took the limit as x approaches negative infinity for x divided by the square root of x squared plus 1, you would have found that the limit value is negative 1. So maybe you might want to try this part right here, like where you try to show that this is equal to negative 1. But if I go ahead and I just, go to the graphing calculator, where we just type it in, and this is no different from me typing it into yeah, the TI-84. No, it's plus 1. So notice that if we have y equals to let's see, 1, and then we have y equals to negative 1, we can kind of see that these functions, they will drastically approach or progressively approach y equals to 1. And the same thing goes for if we approach negative infinity. We have that just goes to positive, or negative 1, sorry. So whenever you get those kinds of questions, yeah, you have to kind of work these out. And it does seem like it's a little different, to be honest. But like if you would have divided by x on top and bottom, or let's say like, yeah, if you would have divided by x actually, then you would have inadvertently probably got the right answer, but be careful with the minus infinity though, because like if you're dividing by x, then you have to account for that. That's the when x is less than 0, which gives you negative 1. Okay, so make sure that you kind of go through the process of how you find limits at infinity. They're more or less not too bad, because if you can just remember, like, if it's the same coefficients, like the degrees, sorry, if it's the same degrees, it's just the ratio of the coefficients. If it's bottom heavy, it's 0. If it's top heavy, it's minus infinity or negative or positive infinity. For polynomials, you just have to remember that either it's up, like it's tending toward infinity, or it's tending toward negative infinity if it's an even degree. But if it's an odd, then it's kind of like it's outward, and then it switches. And the easiest way to do that is to kind of just look at x cubed, x squared, maybe even negative x cubed, negative x squared, and so on. Okay, so these limits are not too bad. You just have to kind of just be able to kind of think of like, what happens if x is arbitrarily large? Where does it tend towards?